Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 21 to 24 of the January 2018 Algebra 2 New York Regents exam. Alright, let's take a look at question 21. It reads, what is the inverse of f of x equals negative 6 times the quantity x minus 2? Alright, let's go ahead and review the steps for finding inverses of functions first, and then we will go ahead and apply it to this problem. Alright, so first thing you want to do is you are going to rename x as f inverse of x and f of x as x. This is known as the switch step. Okay? And then secondly, you are just simply going to solve for f inverse of x, and that, ladies and gentlemen, is the inverse of the original function. Okay? Alright, let's apply to this problem. We have the following situation. F of x equals negative 6 times the quantity x minus 2. We're going to go ahead and carry out the switch step. F of x will be called x, and then negative 6 times, instead of x, we have f inverse of x. So what we're doing right here is we're basically calling the input the output. The input, we're calling it the inverse of the original output, and we're calling the output the input. Alright? So let's go ahead and solve for the new output, and that will be our inverse. To accomplish that, we're going to first of all divide by negative 6, and then add 2 to both sides, and that will be the inverse function. Alright, let's do this. So to get rid of negative 6, we divide both sides of our equation by negative 6. And the negative 6's divide out on the right side. If we switch our equation around, we're going to have f inverse of x minus 2 is equal to negative x over 6. To finish this off, we'll simply add 2 to both sides of the equation, and then we're going to have f inverse of x equals, we can write this as negative x plus 2 or 2 minus negative x plus 6. So if you look at the options that we have here, the 2's come first. So we're going to have 2 first minus x over 6. This is one way you can write it, or you can also write it as f inverse of x equals negative x over 6 plus 2. Alright, so this format right here is consistent with option number 2, which is the answer to question 21. Let's take a look at 22. It reads, Brian deposited 1 cent into an empty non-interest bearing bank account on the first day of the month. He then additionally deposited 3 cents on the second day, 9 cents on the third, and 27 cents on the fourth. Question, what would be the total amount of money in the account at the end of the 20th day if the pattern continued? So we're going to be finding the sum of a sequence of numbers. So the question is, what type of sequence do we have here? Alright, so real quick review on the types of sequences that are in Algebra 2. Types of sequences. When you have repeated addition, okay, when you're adding the same number all the time, or you're subtracting the same number all the time, what you have is an arithmetic sequence. Okay, so repeated addition or subtraction of the same number generates what? Generates an arithmetic sequence. Okay? On the flip side, repeated multiplication or division, repeated multiplication or division by the same number, what does it generate? Well, it generates a geometric sequence. Geometric. Okay? Alright, so let's go ahead and see what kind of sequence we have here. So Brian started with 1, and then he added 3 cents next, and then 9 cents, and then 27 cents, and the pattern continues. So the value of money he adds every time, what type of sequence is it? So 1, 2, 3, if you want to try repeated addition, this is plus 2. 1 plus 2 is 3. 3 plus 2 is 5. So that doesn't work. So let's try multiplication. What if you multiply by 3 times 3? Multiply 3 by 3. That's 9. Multiply 9 by 3. That's 27. Check. This is repeated addition. So this is a geometric sequence. Okay? The sequence above is geometric. Is a geometric sequence. Okay, but what does the question ask us for? The question asked us for the total. Alright? So what do you get when you have the sum of the terms of a geometric sequence? 1 plus 3 plus 9 plus 27. We're supposed to continue 20 times. Okay? So we have this sum going on for n equals 20. What we have right here, this is known as a geometric series. Okay? So this is a geometric series. So let's go ahead and compute what the sum is. Alright, let me just label what this is. This is a geometric series. And then there is a formula for calculating the sum of n terms of a geometric series. The formula is provided for you in the reference section of the test, so you don't need to memorize it. Okay? So the formula that we're going to be using is as follows. The formula for geometric series. Remember, it's just a sum of a geometric sequence. Okay? Formula for geometric series is Sn equals a1 minus a1 times r to the nth power divided by 1 minus r. Okay? Alright, so we just need a1, r, and n, and then we can easily compute what the geometric series is. So let's list what we know. A1 is the first term. A1 is 1. That's the first term right there. The common ratio is what you multiply over and over again. The common ratio is 3. And then n is the number of terms you're adding, which is 20. Okay? Alright, let's just write down what their names are. So A1 is the first term. R is common ratio. And n represents number of terms that you're adding. Okay? What we're looking for is Sn. In this particular case is S sub 20, which is unknown. Now what we're going to do is plug all this into the formula for the sum of n terms of a geometric sequence, and then we'll compute what the sum is. Alright, so S20 is going to be A1, which is 1, minus A1, which is 1, times R, 3 raised to n, which is 20, divided by 1 minus R, which is 3. So let's just simplify it a little bit by hand and then plug it into the calculator. 1 times 3 to the 20 is just 3 to the 20. That divided by -2. Let's see what the final result is. So we are calculating parentheses 1 minus 3 raised to the 20th power divided by -2. And that goes the answer right there. 1, 2, 3, 1, 2, 3, 1, 2, 3. Alright, so let's write down what the answer is. The sum of the first 20 terms of this geometric sequence is, so S20 is 1, 7, 4, 3, 3, 9, 2, 1, 7, 4, 3, 3, 9, 2, 2, 0, 0. Okay, now this is in cents. The options that are provided here are in dollars, so if you want to convert dollars to cents, you just simply divide by 100 or move the decimal point 2 places to the right. So if you convert this to dollars, you just move the decimal point 2 places to the left. Remember, every 100 cents is $1. So the final answer in dollar terms is 1743392. Okay, so 1, 2, comma, 1, 2, 3, 1, 2, 3, comma. Alright, so 17,433,922. The answer to question number 22 is option number 2. Alright, let's take a look at question 23. It reads, if the function g of x equals a times b to the x represents exponential growth, which statement about g of x is false? Okay, so one thing you want to remember about exponential functions that's growing, or exponential growth, so exponential growth functions, one thing to remember is that exponential growth functions are always increasing. Okay, so exponential growth functions are increasing functions. So just to sketch it for you, it looks something like this. You have a horizontal asymptote at y equals 0, and then it just goes like this. It increases in that direction. Alright, so this is an example of exponential growth. Alright, so let's take a look at option 1. It says a is positive and b is greater than 1. Let's go ahead and test that out. So for option 1, test two a and b values that satisfy this condition. So test a equals 1 and b equals 2. Alright, so what we're going to do is we're going to graph the situation where g of x is 1 times 2 to the x, and see if we have an exponential growth scenario. Okay, so we're going to graph and check. Okay, so let's do it. Let's plug this into our graphing calculators. We have y. Let's clear that. And we have 1 times 2. We can just put 2 to the x. Enter. What do you expect to see? It's going to be an exponential growth function. So you see how you have that increasing behavior for the x, for the function, and you see the horizontal asymptote right there. And another thing to note is what the intercept is. It's going to be 0, 2. Okay. All right. So is question one, option one, true or false? Option one is absolutely true because we used two sample values and we arrived at an exponential growth function. So option one is correct. Option two, the y-intercept is 0a. Okay. So we have g of x equals a b to the x. So to find the y-intercept, what do? We set x equal to 0. Okay, so we're gonna go basically look for g of 0. Alright, so g of 0 is equal to a times b to the 0. Okay, so since b is non-zero, b to the 0 is simply going to be 1. G of 0 is going to be a times 1, which is a. So the y-intercept is given by the point 0 for the x, a for the y. Option 2 is correct. Option 3 says you have a horizontal asymptote at y equals 0, and that's exactly what we have here. Okay, you have a horizontal asymptote. This graph gets arbitrarily close to this horizontal line but never touches or crosses it. So bottom line is the exponential function never attains the value of 0. Alright, so based on the look of the graph, this option is correct. Let me show you what I'm talking about. So assuming this is the exponential function right here, this is going to be our horizontal asymptote, this horizontal line right here, and the equation of this horizontal line is y equals 0. Okay, so we have a horizontal asymptote of y equals 0 for exponential growth functions of this format. So we can easily see that the answer is option 4. That's going to be the false statement. Okay. Alright, let's show you that it's false. So the statement says the x-intercept is b comma 0. So if we have this function g of x equals a times b to the x, to find the x-intercept, we're going to set y or g of x equal to 0 and solve for x. Okay. Alright, so let's do it. So we're going to set g of x equal to 0. We're going to have 0 equals a times b to the x. To get b to the x by itself, divide both sides by a. 0 over a is just 0. 0 equals b to the x. To get b by itself, what we can do is we can take the natural log of both sides, or log base b. Let's just take natural log of both sides. Okay, so natural log of both sides, natural log of that, natural log of b to the x. Okay, now on the right side, what natural log helps us to do is it helps us power down this variable. So we have x ln b equals natural log of 0. Okay, so what is the natural log of 0? The natural log of 0 is domain error. It's undefined. Okay, so keep that in mind. The natural log of 0 is undefined. So a natural log has a constraint on its domain. You can only take natural log of values that are greater than 0. Okay, so this is undefined. What does this mean? G of x has no x-intercepts. Because of the horizontal asymptote, it tells you that the graph can never touch this horizontal line across it. Okay, so option 4, which states that b comma 0 is the x-intercept, is false because exponential growth functions of this format do not have x-intercepts. Alright, let's take a look at question 24. It reads, at her job, Pat earns $25,000 the first year and receives a raise of $1,000 each year. The explicit formula for the nth term of this sequence is an equals 25,000 plus quantity n minus 1 times 1,000. question, which rule best represents the equivalent recursive formula? Okay, so let's go ahead and write down the formula for generating a recursive formula. Okay, so formula for recursive formula. Okay, so the recursive formula has two parts. It has first part, A1 is always the first starting term, okay? And then you have AN is going to be the term before plus the common difference or the growth amount, okay, plus the common difference. So this is basically how you set up the recursive formula a for an arithmetic sequence. Okay. Now, how do we know that it's an arithmetic sequence? Well, we know it's an arithmetic sequence because you get a raise of 1,000 every year, which means that you grow by 1,000 every year. You keep adding 1,000 over and over again. Okay? So let me just generate some terms of the sequence for you so you can understand what I'm talking about. Alright? So the sequence is going to start with 25,000. Okay? And then guess what? The next year is going to be 25,000 plus 1,000, which is 26,000. The next year is going to be 26,000 plus 1,000, 27,000. And the pattern continues. So you see that since we're repeatedly adding 1,000 over and over again, we have an arithmetic sequence situation. So plus 1,000 plus 1,000. Alright, so let's write down the recursive formula. The recursive formula for this particular scenario is as follows. We have A1 is the starting term, first term, 25,000. And every other term can be determined by taking the previous term and adding the common difference, which is 1,000. Answer to question number 3. Sorry, to question 24 is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel so you can get updates to the remainder of this review series. If you have any questions or comments, just post it in the comment section below, and we'll be more than glad to support you. Don't forget to check out our website, mathgotserved.com, for access to the transcripts of this presentation and other great tools that can help you pass the Regents exam. Thanks again for watching, and have a wonderful day. Goodbye.